All right, doing the warm up real quick together. When we describe the degree and leading coefficient, we're just looking for degree being odd or even and leading coefficient positive or negative. Okay? So, since they go in the same direction, what's the degree going to be? Odd or even? Even, right? When they go the same direction, degree is even. All right, leading coefficient, we look at the right end. If it's going up, the leading coefficient is what type of number? Positive, yeah. Okay. For this one, degree, they're going opposite directions, so what type of number? Odd. And then leading coefficient, since the right side is going down, what type of number? Negative. Right? That's all I was looking for. Just end behavior. You guys understand that now? Okay? That's pretty easy stuff, right? All right. So, for our homework answers, here's 2, 4, and 6. I'll let you know what those answers are. Check. See if you did that right. All right. So, number 2, make sure it's in the right order. It's not. You got to do. It's not standard form, right? You got to put the 6x to the 4th minus the 4x cubed plus the 1/2 x squared plus the 3x minus 1. So get it in the right order. Okay. It is a polynomial. All right. All our variables are whole numbers, exponents, and all our coefficients are real numbers. Okay. So the degree then would be 4, and the leading coefficient would be 6. And since the degree is 4, what's that special name?
Quartic.
Quartic, right? What's the degree of 0? What do we call it again, just quickly? Constant. 1, linear. 2, quadratic. 3, cubic. 4, quartic. And 5, quintic. Very good. All right. Number 4, is it a polynomial? Do we have variables with whole number exponents? Are all our number coefficients real numbers? Yeah, it's just not in the right order. We should flip the order. It should be 13x squared minus 12x plus the square root of 3 to get it in standard form. So the leading coefficient would be 13. The degree is 2, so it's a quadratic. Okay? Number 6, again, not in the right order. Is it okay to have an x in the bottom for to be a polynomial? No. All right, so we can't have an x in the denominator, so that is not a polynomial. All right. Number 8, it says describe, in 7 and 8, describe and correct the error in analyzing the function. Well, the first thing it says is wrong. It's not a polynomial function. Why? X under the radical sign. Yeah. Okay. That's like an exponent of 1/2. Okay. And they're supposed to be whole number exponents. So that's not a polynomial function. All right. Where do we go next? 10. All right. We're just evaluating these. We're just substituting 3 in for x, -7, -12, and -1/3. So number 10 is 61. Number 12 is 16,193. Number 14 is 2,101. And number 16 is 76/27. All right, that's what, 3 point something if you wrote the decimal. Usually, though, if they give us a value in fraction form, we should probably write our answer in fraction form. If they give it to us in decimal form, we should probably put it in decimal form. Again, you guys have any questions on those? Just substituting in, right? Just putting in the calculators. Should be okay, right? 18. This is the same type of problems we just got done. Now, I think if you were using your online book, I think they forgot to make that a d squared. If you had the actual physical book, or mine, my teacher's edition, it's the d squared. So if you don't have the d squared there, you're going to be a little bit off. But all we're doing is substituting what? 12, right? In for our diameters. That's all we're doing. And when you substitute 12 into that function for number, what is this, 18? You get 8.53 carats. The weight of a diamond they do in carats. All right, but if you'll be a little bit off, I think you might have got 10 point something if that wasn't d squared, if you're looking at it on the online book. Okay, questions? All right, I think that's it for this slide. And then it says describe the end behavior. Okay, so again, I just did arrows with you guys. Since it's a net, is it in the right order, first of all? Yeah. So since it's negative, what's the far right doing? Down, right? And since it's even, what's the far left doing? Down, right? Is this in the right order, number 20? Yes. So my leading coefficient is positive, so the far right is up. My degree is 7, which is odd, so the left's going down. Okay? For number, we did all of those too, didn't we, for homework? Did I make you do all those or just evens? All of them, that's what I thought. All right, 21, it's not in the right order. Here's our leading term, right? Should be first. So it's a positive 12, so far right is up, and my degree is 8, that's even, so the left is up. All right, and the 22, it's also not in the right order. Here's our first term. If we put it in the right order, it's a negative number, leading coefficient, so my far right's going down. It's an odd degree, it's a quintic polynomial, so opposite direction for the far left. We good on that end behavior stuff? Questions? All right. Then we had to graph a couple, didn't we? And I told you could just use your calculator, right? Any issues graphing them? Just plugging it in the calculator, okay? Remember to plug something in the calculator and graph, you need to hit your y equals button to start. Okay? So if we look at the last one, the third, number 30, it's 5, and you can put it right in that order, plus 3x squared. You don't have to change it into standard form. X for the fourth power, remember, hit your caret button here under clear, above divide, and then hit graph. And it looks like an M, okay? It's negative. This is actually the one we want to look at, right? So we know it's going down far right, and it's even, so the far left is going down. And go back to that. There's that graph. Looks like an M. All right, we good? Questions? Wasn't too bad, was it? Okay. Today you need to really pay attention because it gets a little tricky today. But once you go over a couple, figure it out, it's not too bad. All right, so we got end behavior down pat here on the far right, but we're going to talk about positive and negative, increasing and decreasing as well. Okay, so a function is positive when its graph lies above the x-axis. So these blue areas are above our x-axis. Those are when the function is positive. Okay, a function is negative when its graph lies below the x-axis. So these red areas are negative areas because it's below the the x-axis. Okay, does that make sense? Just looking at those. So positive above x, negative below x. Okay. Now I also talk about increasing and decreasing. Okay. Even though the arrow's going down here, if we go left to right, and if I was walking this path, would I be going up along this blue or down? Up. So even though the arrow's going down, it's actually increasing up to a point, and then you can see like at the red part, it's kind of like a slide or something, right? You're going down, that's decreasing. So think about it, reading it like you read a book, left to right, okay? So this red area is where it's decreasing, and then it changes direction again and starts going back up. So it's increasing the blue areas, okay? That makes sense, where increasing part is and decreasing part is. Okay, so what we're going to have to do is write the intervals that it's positive and negative and increasing and decreasing. Okay? We're going to use inequalities to do that. All right? So it says approximate when the function is positive, negative, increasing, or decreasing, then describe the end behavior of the function. Okay? Well, the end behavior part we got, we're not going to worry too much about that. Okay? It might be easier to understand this one first. Okay? Looking at B before we do A. All right, so blue they were making increasing. All right, so let's do, what's it ask first? Positive, negative, increasing, decreasing. All right, so let's just go over here. Positive will make blue, negative will make red, increasing will make green, and decreasing will make purple. Okay? So where it's positive is above, right? So this blue area. Okay? So where we see these changes or these parts of intersection where it hits 0, okay, the x-axis is where it's 0. What's this number on this left dot? 1. What's the right number? 3. So it's positive when it's between 1 and 3. That's our inequality. Does that make sense? Yeah. All right. Looking at the negative part below, that's these red areas, right? That makes sense? Okay. Well, this just keeps going on forever, right? So it's negative when x is less than what? What number's there? 1. And it's negative when it's greater than the 3. Is that making sense? Any questions on that? For positive and negative. Okay? So I'm going to erase those red and X. So I'm going to use green and purple now. Okay, so far so good? Any questions? All right, now it's increasing, thinking of it left to right. If we were walking from left to right, we'd be going up to there, right? What number is up here? What X value is there?
2.
X value. 2. We're always doing the X values, not the Y. We're doing the domain part, okay? So it's increasing when X greater than or less than 2? Less than 2. Oh, I should do it in green, shouldn't I? Sorry. All right, and then decreasing when x is greater than 2. That make sense? Any questions? Right. A little easier when you're just looking at a parabola to tell that stuff. Not too many changes in direction. Okay? Going back up to the first example. All right? So we got our positive and our negative. All right? So positive would be above right? And then we've got it's not positive or negative when it's at 0, right? So we got to there's two areas it's positive. We can't just say from all less than 3, because at 0, it's not positive or negative. You see that? So I have two areas it's positive. Less than 0 and between 0 and 3. You guys see that? There's two actual sections. Again, the reason we have to do that is because at 0, 0, it's neither positive or negative. So it kind of breaks it for a second. Okay? Then my negative area is here, where x is what? What number is that? Yeah, greater than 3. Once we get past 3, it goes down. Okay? So far, so good? All right, and then for our decreasing and increasing stuff, increasing we use green, and decreasing we use purple, right? So let me get rid of those colors. All right, so left to right, increasing, the green would just be from here to there, wouldn't it? That's the only increasing part. So we've got, we got 0 here, and we got 2 there, right? Our x values. So between 0 and 2, right? It's decreasing here, and then there, right? So from 0, less than 0, right? It's decreasing left to right. Okay, so it's all from this end this way, it's going down. And then it did increase, and then from 2 on, right? Does that make sense? I'm putting decreasing and increasing. All right? That's not too bad, is it? Okay. So these points, these vertices, these change in directions, turning points are vertices, and sometimes they're, x-intercepts too, depending on what we're looking at. Positive, negative, increasing, decreasing. All right, that's not so bad. The confusing part's one like this. Sketch a graph that meets all these conditions. That looks like a lot, doesn't it? Okay. Well, let's concentrate on these two first. When it says f of x is bigger than 0, what's it telling you? What do we call numbers that are bigger than 0? Positive numbers, right? And what do we call numbers less than 0? Negative. So we're going to do where the positive areas and negative areas are first. Okay? When we try to sketch the graph. All right? So Between -2 and 3, it's positive. All right. So let me use my finger. It might be easier. So that area is positive, right? Between -2 and +3, and greater than 5 are the positive parts, and then the negative parts are less than -2 and between 3 and 5. So less than -2 are the negative parts, and between 3 and 5. So I got that from those two, the greater than 0 positive. What was positive? Blue we were using before, and less than 0 is the negative. Okay? Now, increasing when it's less than 0. And what do we use for increasing? Green. And then purple for decreasing, which it's already telling us that there, right? So when it's less than 0, it's increasing. All right, and greater than 4. All right, so these points, though, I guess we should, at these points, we have it's crossing, right? It's changing from positive to negative or negative to positive, right? So less than 0, that's on this side. It was increasing, right? I want green, sorry. So right, less than 0 from there, it's going up. So it'll be going in this direction, right? And where else? Greater than 4. So somewhere on here at 0, it doesn't matter where, it was going up, and then somewhere down here at 4, it started going up again. It doesn't matter what our Y values are. Okay, so this side it's going up, and from this 4, it's going up. You guys see that? So I could say from down here, going through those, it's going up. Does that make sense? And then decreasing, purple, what was it telling us? Between 0 and 4. All right? So decreasing between 0 and 4. So that's what it looks like. You can put arrows on the end if you want. What do you guys think about that? All right, so what I did first, remember, is I figured out highlighted areas, positive and negative. Okay? Where the positive and negative areas change, those are our x-intercepts. Okay? And then it told us where it was increasing at 0, okay, and less. So from, it was down negatives coming up, and then it's still going up until I get to 0. And then at 0, it's going to change and start going down until I get to 4. It goes down, and then after 4, it starts going back up again. So again, it doesn't matter where you put the red dots. I could have put them I could have put them down here too. I could have put the red dot here and here, right? I could have made it look like, if I just make it in black, let's say, it could have done this if you wanted it. It's still the same things are happening. Does that make sense? So yours, all of yours won't look exactly the same, but it'll have the same shape. Does that make sense? It's kind of tricky at first. Okay? So again, I would do positive and negative area first. With, if you got a highlighter or something, you want to change colors or something to help you do the positives and negatives. Oh, describe the degree and leading coefficient. Did it ask us on that one? Oh, yeah. So, what degree is it going to be? Even or odd? Right? I forgot to do that part. Sorry. All right, let's go back to a pen, not the highlighter. All right, so degree would be odd because it's in opposite directions, the two ends, right? And then our leading coefficient, since the far right is going up, is what type of number? Positive. Okay? So after we draw it, then we answer those two questions. All right. How much time we got? We're kind of running out of time. You guys want to go through this one also?
No.
We got it? We okay? Or I can go over it if you want. We got it? All right, we're good? All right. So there's your assignment. The first two are just graphing, like we did yesterday. Then the last four are kind of like what we just did. A little positive, negative stuff, doing intervals, and drawing the graph too. Hey, good job today. Thanks for your attention.